Hi, I'm Tim Tyler, and today I'll be discussing how quickly machine intelligence might take off. The basic idea here is intelligent machines will someday be able to improve on their own design, and then they will take off, suddenly producing a period of rapid improvement. Such a scenario presents considerable scope for social, economic and political disruption, since things could then be changing very rapidly. Here is Peter Boss on the topic.
Will there be a hard takeoff? Well, by that is meant that's a scenario of once you reach that basic takeoff, that ready-to-learn state, the seed AI state. Some people speculate that sort of within 24 hours the system will self-improve so much that the singularity will happen, and that's, I guess, sort of the one extreme of a hard takeoff. Other people believe it will take 20, 30, 40, 50 years or something for AIs to develop and become smarter and smarter. My own position is that it will be a firm takeoff. We're talking months rather than years, certainly not tens of years. There will be certain practical limits on how fast the machine can be improved, hardware can be implemented, improved, and systems can be redesigned. But essentially, a very short period in terms of chance for society to adapt to it and embrace it. Certainly, much faster than I believe the legal system can move, or society as a whole can adapt.
One problem with all this is that development will not start from an all-machine seed. Rather, in practice, the seed is like to be an existing company or organisation, in which case, when do we start the clock ticking? For example, if Google is responsible for the first machine intelligence that takes off, should we start the clock ticking in 1996, when Google formed? That's 15 years of self-improvement already, with little sign of advanced machine intelligence. And if not then when? A big complicated company with many humans and machine components is simply not something that germinates at a particular point in time. Also, when do we stop the clock ticking? When the singularity happens seems like a ridiculously vague reply, and it assumes the conclusion that there will be some particular point in time when machines suddenly surpass human capabilities. More recently, Peter Boss has explained one possible cause of slow progress.
So, will it be a hard takeoff? I don't believe so. Not in the sense that it will be an overnight. It'll wake up in some garage or in some basement somewhere, and overnight will kind of take over the world. There are many physical limits that have to be dealt with, physical problems that work at real time. So even though your computer could be solving problems in minutes or seconds, there are things that have to be tested in the real world, and then you're hitting the time limitations, the dynamics of real-world problems. For example, if we wanted a computer to upgrade our wetware, it takes a long time for anything in our brains that we implant or so to heal or to grow or whatever. And that time frame, I believe, will make it a firm takeoff rather than a hard takeoff.
Agents typically learn by performing experiments, observing the results, and then designing new experiments. If those are real-world experiments, then they will take time to perform. However, for some applications, experiments can be done in a synthetic universe. For example, if your driving problem is playing Go. For other applications, experiments can be done in virtual worlds. Also, in some cases, experiments can be performed at incredible speeds, for example, if developing molecular nanotechnology. Not everyone is convinced that the rate of progress will suddenly increase with the advent of human-level machine intelligence. For example, Ray Kurzweil argues against that idea here.
So, in summary, I believe this takeoff is soft. I am a conservative in some quarters. Exponential growth, which will continue based on known physics of information technology and known paradigms and known technologies that are working without any speculative technologies, is gradual, incremental, smooth. There's no silver bullet, but ultimately will be profoundly transformative. Thank you very much.
However, faith in a continued exponential rate of progress is questioned by his opponents. Another skeptic is J. Storrs Hall, henceforth Josh. In a 2008 paper entitled Engineering Utopia, Josh is highly critical of rapid takeoff scenarios. He also presents criticisms in his book Beyond AI. I find many of the points he raises unconvincing, though I generally agree with the spirit of his conclusions. There's more details of my criticisms in the transcript of this talk. Others have argued that technology will exhibit diminishing returns. Observing that many critical scientific breakthroughs, such as evolution, relativity and quantum theory, have already been made, some have argued that scientific development is slowing down and that the lowest hanging fruit have already been picked, and that this will slow down the overall rate of progress. Such views mostly fail to distinguish science from technology. Even within science, while it is true that many fundamental discoveries have already been made, scientific journals are more numerous now than ever and are not running short of material. We will see diminishing returns in technological development in the future as we push up against physical limits. However, for the moment, such limits appear to be far away, and they do not yet significantly constrain development. For the moment, technological development progresses as though some rats have found a large pile of grain. I too have expressed scepticism about the prospect of a sudden takeoff in machine intelligence. For example, see my essay about the intelligence explosion. One of my arguments is as follows. There is not really any such thing as human-level intelligence. Rather, machine intelligence has been gradually surpassing human intelligence for decades now in the context of various different problem domains. Machines can already play better chess than humans. They are already better at performing many refactoring tasks than humans are, and they excel at factoring large numbers, and so on. So, it is likely that human capabilities will be overtaken gradually, a domain at a time. What about the idea that a self-improving system will form in the future and spark a runaway development cycle?
One thing that a lot of people are realizing now is that once we get a sufficiently powerful, intelligent machine, it will be able to understand its own behavior and create its successor, a more powerful successor. And so there's likely to be a kind of, I.J. Good back in 1965 talked about an intelligence explosion of systems that write improved versions of themselves, which then write even more improved versions of themselves. And so as we look forward into time, I think we'll see incremental improvements, the way we've seen so far. And at some point, that loop of systems which are able to improve themselves will be closed, and then we're going to see explosive improvement. And exactly when that happens isn't completely clear.
The idea that a self-improving system will arise at some point in the future seems naive to me. Rather, we already have self-improving systems. They are companies and other organizations. For example, Google is a self-improving system. Machines are already heavily involved in the design of other machines. The idea that machines will suddenly take over this task when they have become smarter than we are seems naive to me. Rather, there is a man-machine symbiosis involved in the design of machines, with the man part gradually being replaced by machine elements. Won't there suddenly be a speed-up when humans are finally eliminated from the loop? Probably not. By that point, automated code wizards will be writing most of the code anyway, so progress will already be pretty rapid. Also, humans will probably mostly want code reviews afterwards, and enforced controlled assent to make sure that their new toy does not get out of hand. Werner Vinge claims that a rapid takeoff would be regarded as undesirable.
The extreme version, what I call a hard takeoff, where it all happens in 100 hours or so, that sounds very scary to me.
Yeah.
And yet, reasoning by analogy, that's not. I do not regard that as implausible.
Right, so humans would recognise that and act to slow things down if progress showed signs of going too fast for the constructors. It's been argued that the first superintelligent agents will be able to capitalise on various resource bonanzas, resulting in a discontinuous leap forwards. One such resource is existing computer networks. However, the idea that such networks will not be being exploited before machine intelligence arrives seems strange. The worldwide mesh is a long-predicted phenomenon, and we have already had some glimpses of such networks in the shape of the ones that have already formed, and which are used to factor primes, search for extraterrestrials, send spam, and attack rival companies. Another such resource is existing experimental data, information which we have failed to make full use of so far. Well, papers reanalyzing the data of others are constantly being written, and new tools for finding correlations and links between papers are evolving too. Yes, a superintelligent agent will munch through this material someday, but the munching began long ago, and it seems likely to gather pace before we have superintelligent agents. The possibility of a rapid takeoff is greater if machine intelligence is a problem that can be solved with one big insight, and it is lower if it takes many small insights to solve the problem. So far we have seen slow, gradual progress in machine intelligence. We cannot rule out the one big insight hypothesis completely, but there has been little or no sign of such a thing so far. Brain emulation enthusiasts have speculated that we will get useful machine intelligence suddenly when we first successfully boot up an emulation of a scanned human brain. However, this scenario seems too ridiculous to discuss further here. The argument that we are unlikely to see a sudden jump in machine intelligence capabilities is not an argument that we will not see rapid progress. We will probably see extremely rapid progress. The idea is an alarming one, since rapid progress has the potential for disruptive power shifts. Enjoy.